Welcome to Module 55 of AP Environmental Science, which is looking at alternative ways to handle solid waste and what we should do with it and how we can reduce the amount of solid waste generated. I'm going to start over here with our life cycle analysis. Life cycle analysis is a very holistic way of looking at a particular product and looking at its life cycle, so to speak, from the cradle, so the time it was initially created, all the way to the grave. So this is looking at how are the components of that particular product produced, what are the raw materials, and what are the steps that happened in the production of that particular item. Are there any waste products produced during the everyday use? And then the grave. So when it is finally done with its normal lifespan, its predicted usability, what happens to it then? Is it recycled? Is it broken into its initial parts? Are they then reused again? So cradle to grave is this birth to death type analysis. There's also proponents for the argument of cradle to cradle. So looking at a particular product and saying, well, where did it come from? How did we use these materials to create it? But then how can this product itself, when its usable life is over, be turned into the raw materials to create something new? So that's kind of this birth to rebirth way to look at things. Now there's several challenges to a life cycle analysis. The biggest one is it is very, very difficult to determine what all the components are and break them down to their small initial raw materials, and then analyze the actual environmental impact of each of those pieces. It takes a lot of work, it takes a lot of time, it's very detailed, but it's important to understand, is it better to use a paper bag or a plastic bag at the grocery store? You need to do a life cycle analysis to figure that out. The reason why it's so important to do this is because disposal of solid waste is often very, very expensive. So it's hard to justify a set of land to be a landfill or to build an incinerator. They cost a lot of money, take a lot of land space, cause a lot of pollution issues, so it's very expensive. And oftentimes it's easier to reduce the waste being produced in the first place than it is to find a way to dispose of it. And that brings us to integrated waste management, which this particular approach uses multiple strategies to reduce the total amount of waste. So along that whole life cycle analysis process, we're looking at, all right, with our manufacturing, can we choose a package design that's going to have less waste? When that particular item's being used, can we increase the amount of reuse of that item? So if taking about paper bags, like grocery bags, maybe if we make the bag just a little bit thicker, it can be used more than one time at that particular store. And then the waste at the end of that life cycle, is there any part of that product that can be recovered through recycling or composting? So we're trying to reduce the source of the waste, and we're trying to reduce the overall waste. So integrated waste management is trying to use these multiple strategies. Last page of the module already. The biggest takeaway of integrated waste management is that products should be designed for this cradle-to-cradle mindset. So they should be designed to be recycled. This image here is a recyclable carpet. So instead of putting a single piece of carpet across the entire floor, it's broken up into individual carpet squares that are just that top surface layer. So if you get a stain on one of them, you don't have to replace the whole carpet, you don't have to make that whole thing be wasted, you can replace just the one square. So we're reducing the total amount of waste that's generated. There's also a push to look at the natural world for new materials. So for example, that's in the textbook here, is looking at turtle shells. Turtles produce this really strong outer shell, but they don't produce any toxic waste in the process. So it's looking at the natural world to try to find inspiration and understand these processes that happen naturally, that don't have any solid waste or toxic waste, and seeing if we can replicate them as humans to produce our products. Whew. And then the final piece is upcycling. So looking at a product that's at the end of its usable life and turning it into something new that can again be useful to kind of extend the total life of that product. Now I briefly want to talk about the working towards sustainability. I don't always do this in the videos. The working towards sustainability is talking about e-waste, so electronic waste. Oftentimes, e-waste is shipped off to poor countries to be disposed of. And oftentimes those countries don't have the facilities to be able to process that waste, because a lot of our electronics contain huge amounts of heavy metals and other major pollutants that require specific processes to recover them. This working towards sustainability talks about a company in South Africa that was able to develop an e-waste recycling facility, and it talks a lot about how they were able to create this national strategy to reduce the amount of electronic waste produced within their country and within their community, and how that kind of reflected also in Rwanda. So it's a great read. It's a great little bit of detail to add in there. Make sure you took good notes. Make sure that you're asking lots of questions in class.